Hi, today I'm going to give you explanation about the double pointers. We will start with a piece of a program to show you how the double pointers work with static memory, with stack memory. Then we go to the heap, dynamic memory, and finally I will show you example of linked list that we are using in our lessons. So let's start with the stack memory. So there is a small program which just declares a few variables, so one integer, one pointer to integer, and one pointer to integer. So let's start. What happens? Now, first I declare a and define it to value of 5. Then I declare pointer p1, which is going to point to the address of integer a. And then pointer 2 or double pointer, which is going to point to address of pointer 1. And now if I change the contents of pointer 1 to 6, the memory is going to change. And if I'm going to change the contents of the pointer to the pointer 2 to 7, the memory is going to change too. So, very simple set. Double pointer is just like another other pointer, but it doesn't point to something like integer or structure or whatever, but it points to a pointer type. That was the small example of stack memory. Now let's have a look what happens if we do this with a heap, because that's much more used. So again, I have a small program here, and what I did, I actually declared again a single pointer, a double pointer, and then I want to change the contents of pointer 1. And if everything goes okay, it should go wrong. And I will show you why. So we have pointer 1, and now I want to put something in the contents of the pointer 1. But where is the content? In the other example here, the contents was integer a here. So pointer points to a. Now we don't have anything, so the program should actually crash. So let's see what happens. And you can see use of uninitialized value of size 8. So if we are really trying to size 8 is the pointer value, which is not initialized, and we want to put something in the memory, so the program doesn't like it. I'm showing this to you because I've seen this so many times in the code. So please, you can't just declare pointer like this, which is not pointing anywhere, and then assign it the value. No, you really have to allocate. So let's change the code. Now I'm going to use dynamic heap memory. And this is quite comparable to the example that we already had with the stack memory, with the local one. And just shows you how it works with heap. So again, we have 2 pointers, from which one is double and one is single. Now I'm really going to alloc the integer for this pointer because I really want to have a place where I want to write. Then I'm going to alloc again pointer 2, but the type I want to alloc is actually pointer type. So the pointer 2 is going to be the value of that pointer is going to be pointer again. So you can see it here. Okay, so we can also see here integer, pointer. That's the difference. And again, I'm going to put a value of 5 and a value to pointer 1. So I changed the value that I allocated. Then I'm going to point pointer 2 to where the pointer 1 is pointing. See, to the same space. Watch out, that this is the contents of pointer 2, which is a pointer again, pointing to value 1. I know it's confusing, but that's why I'm showing you the picture. And now again, the contents of pointer 2 became 6. So that was how it works with dynamic memory. Of course, at the end of the program, we have to free all the stuff, but I didn't do all of this safe programming and here, because it's just to show you how the pointers work. And now let's go to the real example, the way we are actually using this in with a list. And I heard many students asking, why do we need double pointer when we do some stuff with the linked list? And I hope to be able to show it to you. So what I'm going to do, I'm going to compile the code that I created. I created a small code which actually just creates a list, adds a first element to the list, and again, so at the end it should look something like, I will show it to you, like this. Which is here value 5, oops, and here value 6. And this is the list. So that's what we want to get. So, sorry, value 6 and value 5, of course. Because first we add first this value and then we prepend value 6. Okay? So that's what we're going to do, and I hope you can see it. And I hope you can see what's going wrong once we are going to use just a single pointer instead of double. So, okay, I first initialize to 0, because if it's 0, we just very simple prepend the value, you'll see it in the function. By the way, watch out, this function is not complete, there are no checks, it's just a very small extraction of the real functionality to be able to show you what I want to show with the double pointers. So again, I'm allocating item because that's the value and pointer to the next one, as I just showed you in the picture. I put the value of 5 because we had here value of 5. And please never ever forget immediately to initialize next value because it's causing problem if you don't initialize to anything. So I don't know where it's going to point now, but anyway, it's going to be end of the list. So it's 0. The list pointer, as you can see, is 0. So only thing I'm going to do, I'm going to replace a list with item. So the list is going to point to the first item. You can see it. And you can already see it. So this is the list. So it's pointing here. But in the main function, is list still 0. So once we return, we lose everything. We lose this. Because we changed the contents of the pointer which was declared here. So how to solve it? To be able to solve it, we need pointer to pointer. Let's see. I'm going to do this. And then I'm going to declare this as pointer to pointer. And I will check it here. So there is the referencing of this And let's see, I hope I didn't make any mistake. Let's see what happens. So again, now we have a double pointer, which we initialize to 0. Then we go, sorry, this was wrong. Actually, we have to have like this. It's strange that the compiler didn't actually complain. So we have a pointer, and to be able to use double pointer, we use address of this variable. Okay, so maybe you can see it like this at the end. There will be something like this ampersand, so it's address of this. That's ampersand. So watch out, that's the address of the list. I'm going next. So that's the ampersand, so it's address of the pointer. And now you can see this is still 0. It points to this variable C, so we use address to point to this list. Now again, we just alloc memory, and we know that the value of this is 0, so it's not, there is nothing inside, so there is empty list, so we just add the item. But as you can see, both the pointer in main, the list one, and the pointer in this function point to the same value, so we don't lose it. So once I go back, I still have this list pointing to the value 5. And I'm going to do exactly the same with the value 6, just to show it to you. So next, we create an item, we give it value of 6. Again, we initialize it to null. Now the list is not null anymore. So what we're going to do, we're going to prepend this item to the list. So the next value is going to point to the value of the original list. See? And don't forget, again, to change the list so it's not pointing here, but at the front. That's also a mistake that happens many times. So now you can see again, list here in the main and list in the at first that point to the same value. So I can very happily go back and return to the main function. And that's the way it should look like. I hope, you learned something about the real use of the double pointer in C. It's mostly used in APIs where we want to pass some structures the address of which are going to be changed.